Notes 9.3, the behavior of waves. Oh, yeah. All right, so here we go, reflection. Remember, all waves echo or reflect, okay? And there is that, you can see here what's going on. I love this dog. The light is hitting the dog, bouncing into the mirror, bouncing off the mirror, and then the dog sees it and it's causing the dog to flip out. So these are light right here, reflection of light waves. Echoes, and here's an echo. What happens is in an echo, that wave bounces off one object and bounces back and forth. Now, the reason this is kind of cool, certain materials reflect better than others. And when you have a really rough surface like a brick, and an echo here hits it, it can bounce in many different directions. So sometimes when we're ghost hunting and we hear a voice or an echo or a voice, people think it's echoes that could have been bouncing around in that room for years and years and years that is picked up by your recorders and that. But pretty cool picture, echoes. The law of reflection, chunk getting hit by the machine gun, getting nailed, but bouncing off. The law of reflection, remember, the angle of incidence always equals the angle of reflection. Refraction. And refraction is the bending of a wave due to a change in a medium, okay, or in a material. In the lecture, I show a block of glass and how the light wave is transferred or refracted through that glass. And here you can see too, this middle spot, this middle part is so thick and slows the light wave down so much, you can't even see the center of the test tube. It's not even visible, okay? But when it changes speed entering the water, it appears again. It's kind of cool. But this oil refracts it so much you don't even see the test tube in there. Here's some other refraction. And this is just simply from the light waves being slowed down. Light waves being slowed down when they're reflected back into your eyes. And that's pretty neat. All right, diffraction. Diffraction is the bending of a wave, and you can see this is what was in our book, but this is live action. Crests are the light spot, troughs are the dark spots, and as you can see, as they hit this, they are diffracted. They change direction. They're going straight. They change to a bent wave, moving out in all directions. Okay. And again, just like in the notes, if you're trying to hear somebody out here is talking, they're whispering and you want to know what they're saying. The worst place to stand is right here. There's no waves. You're better off standing back in these corners. You'll be able to hear them better, believe it or not, from here than you will right here because there's no sound here. These are known as like a shadow zone. And again, here's just another picture of it. A large aperture and low levels of cause low levels of diffraction, and small aperture diffracts the wave more. It's just saying, hey, if there's a large opening here, we're not as diffracted as much as we are if it's a small opening. Interference, we can have constructive interference and destructive interference. Constructive interference here, red plus blue equals purple. Our crests and our troughs match up. So I add these two together to get the new wave. All right. Destructive means that the crests and trough do not line up. They're opposite each other. And when they're opposite of each other, they cancel out. All right. And you get no wave at all. So let's look at a little constructive interference. He's constructing. I don't know, man. I just think this is nuts. He's building stuff. And then how about a little destructive interference where he's busting stuff apart? Yeah. All right, that's it for the notes. I hope they help you out. Good luck.